All right, so now I've started recording. Okay, welcome back. We are going to go through the 2020 paper 3. So please have it in front of you. Like I mentioned, we will not be going through every question. So for the questions that I do not go through, I will put the answers up on OneNote very shortly by tonight so that at least you are able to revise on your own. Okay, now I will be skipping question 1 and 2. All right, let's go straight to question 3. Now, question 3 is simple but difficult at the same time. In fact, question 3B looks somewhat familiar because actually your prelim paper was modeled after this question. But before we get to 3B, let's go through 3A first. Now, recycling of metals. Recycling is a common question tested, right? You need to know the reasons why we recycle. You need to be able to tell me what happens if we don't recycle, okay? So this is about recycling metals. There are 3 main reasons. Now, what are the 3 main reasons? The first reason is obviously to conserve limited natural resources of metals. This one, I think most of you can quote this reason. You understand this. The resources of metals are limited. Okay, they will run out one day. Okay, it's not infinite, right? Okay, if you don't recycle now, you will run out of the metal reserves one day. The second reason is to reduce the environmental pollution or environmental problems caused by extraction of metals. Now, this is very important. Don't just say reduce pollution. Reduce pollution caused by the extraction of metals. So for example, iron. Iron is extracted from hematite. But this process will release harmful gases such as carbon monoxide. That's harmful, right? It will pollute the atmosphere. So extracting iron will release carbon monoxide, which is harmful to the environment. So please be specific. Now, reason 1 and 2, I think is quite straightforward. Okay, you are probably able to understand and remember this. I hope you do. You need to know at least these 2 reasons for recycling metals. Now, what is a third reason? Now, common sense reason, all right? Through recycling, we will help to save energy and costs associated with extraction or mining of metals. Okay, so think about it. Okay, if you want to mine for iron, you need to have labor, right? You need to pay people to go to the mountains to look for the hematite. And then at the same time, blast furnace to extract iron, it needs to be very hot. You need a lot of heating, right? The heat energy will cost money as well. So by recycling iron, we will help to save on these energy and costs. Okay? Again, don't just say energy and cost, must say that it's associated with extracting metals. So these are the 3 reasons why we recycle metals in general. All right? So this is easy but difficult, right? I think most of you probably only remember 1 or 2 reasons. It is time to learn all 3, okay? Now, part B. Now, part B is not difficult. Part B is really regarding salt prep. And in fact, the student has written the instructions out for preparing iron 2 sulfate. Right? However, the students have made several mistakes in the instructions, meaning before you start doing anything, can you please read the instructions that they have written? If you don't read the instructions carefully, line by line, you're going to miss out. All right? First step, wear safety goggles and gloves. Obviously, great, correct. You need to wear safety goggles and gloves because you are using acids, right? You should wear gloves to protect your skin from the corrosive acid. Next, start with iron fillings. Good. You need to have iron what? Iron reacts with acid. Next, warm excess iron with concentrated sulfuric acid. This is the first problem, right? We do not use concentrated acids to react with your metal. In the lab, it's always dilute HCl, dilute H2SO4. So concentrated is wrong. All right? Can? So this is the first mistake. Warm excess filings with concentrated sulfuric acid. So this is a mistake. Now, for prelims, we allow you to just write step 3. Can we not do that? Can we quote the proper phrase out, the part there's a mistake? In fact, I will even underline what's the mistake. The underlining tells me that, oh, concentrated is wrong. So what should we correct to? Dilute acid. In this case, dilute sulfuric acid, I think, should be used to react with iron. Okay, iron filings are F-I-L-I-N-G-S. Now, is this the only mistake? Actually, we read on, that's not the only mistake, right? This step, the formula also wrong, no? Fe2SO4 that's not iron 2 sulfate, that's iron 3 sulfate. All right, so again, iron 2 sulfate, Fe2SO4 this is wrong, so underline the wrong part. The formula of iron 2 sulfate, iron 2 means Fe2 plus, right? Fe2 plus, SO4 2 minus, it should be FeSO4. So actually there are 2 errors in step 3 alone. All right, the first one has to do with concentrated acid. The second one has to do with the formula of the iron 2 sulfate. Okay, let's take this down first before we move on. All right, moving on. Step 4, filter the solution to remove any unreacted iron. Oh, this sounds familiar. Mr. So has taught this before. We add excess solid, right? Excess iron in this case. So there will be unreacted iron left behind. You must filter to remove the unreacted iron. This is similar to how you would filter to remove excess unreacted zinc carbonate, right? Zinc oxide. Okay, so this is salt prep. Remember, you add excess solid, then you filter to remove the excess unreacted solid. All right, gently heat the solution until brown crystals begin to form. Again, this is wrong, right? Iron 2 is not brown. Iron 2 will be green. So this is step number 5. Gently heat the solution until brown crystals begin to form. So this is the mistake. Again, underline the mistake. All right, brown is the part that's wrong. So what should you correct it to? You need to gently heat the solution until saturated. Okay, but let's also correct the color part. Now, if it's saturated, means the water has evaporated such that you should see crystals begin to form. The crystals will not be brown, it will be green. Green crystals begin to form. How I know it's green? Because it's iron 2 sulfate. Fe2 plus iron 2 is green. Okay. Okay, next. Instruction number 6. Okay, so after your crystals form, leave to stand, separate the crystals by filtering. That's correct. Okay, you need to filter. Remember, you need to filter to collect the crystals at the end. Then you must wash the crystals. But the next part, do you wash with large quantities of distilled water? No, right? So again, you do not wash with large quantities. Okay. So we will never use large quantities. We will wash the crystals with a little cold distilled water or small amount. Okay. Okay, distilled water is water obtained from distillation. All right, so it's pure water. Okay, no minerals, no dissolved ions. All right, so please take note. All right, you do not wash with large quantities of distilled water. All right, you must wash with a little, okay, small quantities, small amount of cold distilled water. So these are the 4 errors. Then you must be thinking, but the question only asks for 3 errors, right? That's the point. Whenever you have questions like these, where there's a lot of marks, typically there are more marking points than there are marks. A 6-mark question may very well have like 8 marking points, as you can see. All right. So you just need to hit 6 correct marking points to get 6 marks. So that's why Mr. So keeps on telling you, provide details, give details. Because when you are giving details, you are hitting more marking points. You are maximizing your chances of doing well. All right. Of course, you must manage your time. Remember, we said this before. Section B, you must leave 30 minutes to do it properly, which is to say during the exam itself. Look at the digital clock that's in front of the hall. Once the clock says 3:15, 1515, it's a signal for you to move on to section B, because you need 30 minutes to do it properly. And section B is where you can score if you provide the details. All right. Okay, so with this, we have finished question number 3. Do you have any questions that you would like to raise? Okay, if it's done, you can also give me a thumbs up so that I know you're done. All right. Now we try to avoid just writing the step number there, because I feel that you should provide the details and really identify which part of the step is wrong. Okay, Ken? So the student's mistake column is good to write which step is wrong and which portion, which particular word or phrase is wrong. So that at least you show the examiner that I have more understanding. Not only do I know that this step is wrong, I can tell you which part is wrong. Yeah. Okay. Now, this is also similar to your prelims, all right? So again, you might want to look back at your prelim papers to see what mistakes you had made back then. All right, let's go to question 4. Now, question 4 is unfortunately really complicated. All right. Now, it's complicated because you start off with a mixture of A and B, okay? So you already know that the starting is not just one thing. There's A and there's a B, right, in the same mixture. Now, as usual, good chemistry students will start with the gas first. So obviously, this gives a white PPT with lime water. This is carbon dioxide. So this is important because once you know it's carbon dioxide, you can trace backwards. This means that A and B, one of them must be a carbonate. Okay, so A is the carbonate, B is some metal. How do I know that? How come Mr. So knows that B is a metal? I read on the next line. Metal B, right? So B is a metal. All right, B is not a carbonate, A is a carbonate. Okay? Now, in fact, I can already work out what B is. You read, A and B is a mixture. It was reacted with sulfuric acid. The question now is, did sulfuric acid react with both A and B? So if you read what comes next, you realize that B doesn't react with acid. Because it started off as B, after adding acid in, it still ended up as B. It didn't change. B remained unchanged when you add acid. So it shows you that B doesn't react with acid. So it means B is a metal that is unreactive with acid. What metals are unreactive with acid? Copper, silver, gold, right? How do I know it's copper? So remember, good chemistry students, gases. Next one is color. Look at the colors that are formed. A B, metal B gives you a black powder and blue solution. No, blue leh, blue leh. Blue means copper, right? So B is copper, metal. Now take note, it's not copper 2 metal. Metal, there's no 2. Metal got no charge. All right, it's just copper. Okay, so now that you know that B is copper metal, let's just copy it down. All right. So what is C? Now C is when copper metal is heated in oxygen. Copper 2 oxide. All right. So when do you write 2? You write 2 when it's combined with another element. So in this case, copper has reacted with oxygen to form a compound. So the compound must be copper 2 oxide. Why oxide? Oxygen forms oxide. Okay. Then you are told that the black powder C, which is copper 2 oxide, you react it with sulfuric acid. Okay, so sulfuric acid gives you the sulfate, so it's copper 2 sulfate. So you have solved B, C, and D already. Okay, so at this juncture, you have solved half the question. There's only the other half that you need to look at. So you realize, again, we start with gases. Then we go to the colors. In this case, blue. Blue tells you it's copper 2, right? So in this case, copper 2 sulfate. Okay, can? Now you need to get used to this. If there's anything to go by, I think QA is getting harder and harder in the sense that instead of just giving you one thing, over here is a mixture of two things that you started with. You started with a carbonate and copper metal. Okay, so there's double the number of things that you need to deduce. All right, moving on. Let's move to the other side, the left-hand side branch. So now we have finished gases, we have finished color. Now you look at solubility, whether the precipitate is dissolved or not. So when you added aqueous ammonia, it forms a white PPTF. White PPTF dissolves in excess ammonia, meaning F must be zinc hydroxide. Only zinc ions will produce a white PPT that dissolves in excess aqueous ammonia. So it's zinc hydroxide. So you have to remember that when you add ammonia or when you add NaOH, the precipitate is always the metal hydroxide. So in this case, zinc hydroxide, which is to say, E must be zinc something lah. Zinc what? So you look backwards, hello. Over here, you added sulfuric acid, right? Sulfuric acid must be sulfate. Okay, so zinc don't have to put 2, zinc is just zinc sulfate. Because zinc only has 2+, zinc doesn't have other charges. Now A, therefore must be zinc carbonate. All right, if not, where does zinc come from? Right, the zinc must have come from zinc carbonate. So A is zinc carbonate, B is copper metal. All right, so let's now name it. Now, when we ask you to name, try to spell the name out. So A is zinc carbonate, B is copper metal, C is copper 2 oxide, okay, D is copper 2 sulfate, E, what's E? E is zinc sulfate, and then F is zinc hydroxide. Okay, I sincerely hope that those of you on Zoom, you have done 2020 paper. I hope that out of 6, you can at least score 4. Okay, so this is not easy, but I don't think it's impossible to do. Next, write a balanced chemical equation with state symbols. Choose the acid reactions, okay? In this case, zinc carbonate plus sulfuric acid. Okay, zinc sulfate, which is aqueous, it's a solution, plus CO2 gas plus H2O liquid. Why choose acid reactions? Because acid reactions are straightforward. You have learned how to write them many times, right? Acid plus carbonate gives you salt, carbon dioxide, and water. O2. Okay, so try to do acid reactions equations where possible, all right? Okay, so I hope that you have done this question. Okay, you are able to get all 6 correct. If you are not able to get the 6 correct, it could mean that at certain points, there were some logical gaps, meaning you need to brush up your knowledge of QA. It doesn't mean that practical is over, QA is over. QA could appear in theory just like this. It doesn't mean that if it's organic chem, then there's no more QA. Nope, there could be both. All right, so you shouldn't spot topics, study everything. All right. All right, now let's move on to question 5. Now, question 5 is quite challenging. Part B, that is. Part A is quite okay. Now, ethanoic acid and ethanol can be distinguished by chemical tests. Describe 2 of these tests and observations, right? Now, the first test is a test for acid. Now, when you want to test for acid, there's only one way. It's best to add a carbonate. So I will add aqueous sodium carbonate to both ethanoic acid and ethanol. Okay, if you are lost, go back to my carboxylic acids notes. This is one of them. I even made your copy down that sodium carbonate is a good test for carboxylic acids. Why? Because you will have effervescence observed as ethanoic acid reacts with sodium carbonate. To form CO2. Okay, so ethanoic acid is a typical acid. It will react with carbonates, all right, to form CO2. No visible change observed with ethanol. Ethanol doesn't react with sodium carbonate at all, all right? Okay, so that's the test for acid. So sodium carbonate is test for carboxylic acid. Must know. Now, so how do you test for alcohol then? Okay, you will add acidified potassium manganate 7. All right, I will just write the formula KMNO4. All right, so acidified KMNO4 is a good test for alcohols. Why? Because ethanol will decolorize the acidified KMNO4 from purple to colorless. So ethanol, alcohols will decolorize acidified KMNO4 from purple to colorless. There will be no change observed, no visible change observed with ethanoic acid. Okay, so these are the 2 tests you need to know. Sodium carbonate, test for carboxylic acid. Acidified KMNO4, test for alcohol. Okay. All right. Now,
Wait, sorry, teacher. I suddenly cannot hear you. Is it my problem or what?
So wait, can let me copy?
Okay, can you hear me now? Okay, Irfan can hear me, but the rest can hear me or
Yeah,
not?
I can hear I can hear.
Okay, so I guess I was talking to the wall just now. How long has it been since you last heard me? Did y'all catch the
This
part
also.
about planning?
Can you let
No.
me copy down first?
Okay, let's copy down this one first, okay? Now, if you cannot hear me, you need to stop me, all right? Sometimes I might have misclicked, okay, and it went to a different microphone system. All right, so as I mentioned, if you studied the organic chem summary, you would be able to come up with these two tests. Test for carboxylic acids is to add sodium carbonate solution. Test for alcohol, add acidified KMNO4. Okay. So Yiling, do you hear the part just now or not? The previous question 4, question 3, you got hear or not?
Yeah, I got here.
Yeah.
Also, it was only question 5 lah.
Yeah, I think I think I hear your explanation about the part A, then I cannot hear.
Okay, not so bad, not so bad. Okay, so at least my Zoom recording will not be totally messy. Okay, but that's the reason why we attend Zoom lessons instead of watching the recording, right? So they get a live experience. I didn't want. The recording is on, right? Okay. All right, let's go to planning. Planning. Okay, as mentioned, I think I've said to you all many times in class also. Okay, planning for pure chem students is in the practical paper. So the practicals, the pure chem students finish planning already. All right. But for combined science, planning is in syllabus. It's in syllabus. You need to know how to plan experiments. So in your theory paper, paper 3, there will be one question that asks you to suggest apparatus or plan a simple experiment, just like part B. So part B is the main reason why I want to go through 2020 paper. All right, how do you plan an experiment? So first, to plan an experiment, you must first read the question. So in this case, highlight chemical names, ethanol and propanol. You are told that both of them are alcohols, which are oxidized to acids when left open to the atmosphere. Now, they want you to plan an experiment in the lab to determine which alcohol is more quickly oxidized by air. Now, this is the problem, right? So you cannot just anyhow plan an experiment. You need to realize that when it's oxidized, it will form acid, carboxylic acids. So how do you know if it's acidic or not? How do you know if it has formed the carboxylic acid or not? Can you observe? Well, the best way to do is to measure something, right? You have to measure what? How do you know whether it's acidic? You measure pH. Do not just use indicators, measure the pH. How would you measure pH in the lab? You will use a pH meter. All right. So I hope you realize by now, do not just use very simple experiments. I just put litmus paper. That won't work. You need to have measurements. Just like how you measure temperature using thermometer, you can measure pH using a pH meter. All right. You need to realize that acids, when it forms the acid, the pH will go down. Okay. Can form acids, pH will go down, right? We should know by now, pH will become lower. Okay. All right. Next, when you plan an experiment, you must decide what do you change, what do you keep constant. In this case, the only thing you should change is the alcohol. Is it ethanol or propanol? Do you change the volume? No. Do you change the temperature? No. Do you change the amount of time? No. All right. So the idea is you need to keep things constant, change only the variable that you are investigating. You are investigating which alcohol is more quickly oxidized. So you change the alcohol, you shouldn't change other things. So let's start. Now, when you do experiments, you must always state the steps clearly in a way that people can follow your experiment. So you should place 50 cm cube of each alcohol into, you can use a beaker, into clean beakers. Now, it's important to show that you know quantities are 50 cm cube is a reasonable amount. Now, you are measuring pH, but don't wait until the end that you measure pH. You need the starting pH also. Measure the initial pH of each alcohol, okay, using what we call a pH meter, right? Okay. Then you leave both beakers open or exposed to the atmosphere. I'm just using the words in the question. Now, this is where you need to be careful. When you leave open to the atmosphere, you must state how long, right? So not every 30 seconds, 30 minutes, right? Oxidation takes time. Maybe like 3 days. Okay, you can choose 5 days, 10 days. But the idea is, please choose something reasonable. It's like rusting of iron. Remember the previous paper we went through rusting of iron? Rusting of iron is not completed in 5 minutes, right? Rusting of iron takes like 5 days. Similarly, this might take a few days to happen. Okay, so this is one of those slower reactions. Then at the end of 3 days, what do? You measure the final pH of the mixture in each beaker. Okay, so you must also give me a conclusion. After you measure pH, so how do you know which one is more quickly oxidized? So you think quickly oxidized means should form more acid. Form more acid means pH should be lower. So the alcohol that produces more acids will have lower pH, meaning it has oxidized faster or more quickly. All right. So do you realize Mr. So has been training you all for all this planning in the speed of reaction? Actually, you look at my speed of reaction notes. There's one whole section on planning. It's quite similar to this, right? That's why you must study the speed of reaction notes. Now, the marks are always given as such. Okay, you must tell me what to measure. What to measure is 1 mark. All right. Giving me reasonable quantities like 50 cm cube, 3 days, that's another 1 mark. Giving me reasonable apparatus is 1 more mark. So it's 3 marks already. The last 1 mark is the equation, is the conclusion. How do you know which one is oxidized faster? Based on the pH. So how do you use the results to give me the conclusion? Okay, this is 4 marks. So you should not get 0 out of 4. You have been warned. Don't say that planning is not in syllabus. Planning is in syllabus. So where's the best place to study? Of course, study the papers that have the planning question. So remember this question now is in 2020. You should study this before the O-level paper. Similarly, you should also study my speed of reaction notes. Page 12 to page 15 is this thing, okay, how to do planning. Okay, please don't say it's optional, it's not. All right. All right. Now, with this, we have finished question 5. Mr. So is going to skip question 6. Mr. So is not going to skip question 7. So let's go to question 7. All right. So may I move on to question 7? Are you done with question 5? Give me a thumbs up if you're done. All right, moving on. Question 7, please. Thank you. Okay, so tantalum is a rare metal. It has 5 valency electrons. Valency electrons is the same as valence, okay? It's just different ways of writing the same thing, all right? If it has 5 valence electrons, it can of course gain 3. But let's look at the question. They're asking for chloride and oxide. They already told you that tantalum is a metal, right? Metals lose electrons, right? So in this case, it will lose 5 electrons. So it will form 5 plus charge. Okay, this is a bit unusual, but the clue here is metal. They told you that tantalum is a metal. Metal lose electron. Right? That's why we call things a metal. Metals lose electrons. So in this case, the clue to you is metal. All right. I know usually if you have 5 valence electrons, you will gain 3. But that's for non-metals like nitrogen. Here, tantalum, they told you is a metal. So metals will lose electrons. So with that, I'm sure you can deduce it's TaCl5. The oxide is Ta2O5. All right. Now next, the reaction is exothermic. Oh my God, didn't we just go through this? Exothermic means the reaction releases heat energy to the surroundings, okay? All right, so with that, we have finished part A and part B, part 1. So can we ensure that we have understood this before we move on to the redox? Okay, so now in this reaction, sodium forms sodium fluoride. Sodium forms sodium fluoride. So now they're asking you, has it been oxidized or reduced? The best way to do this is to think of oxidation states. The OS as sodium. Sodium is an element. It hasn't combined with anything. It's just Na, right? If it's just Na, it's 0. Remember, the oxidation state of an element is 0. How do you know it's an element? Look, is it combined with something else? It's not. Na is just Na at the start. But at the end, it forms NaF. NaF contains Na plus, right? So the oxidation state is plus 1. All right. So sodium has been oxidized. And the explanation, the oxidation state of sodium increased from 0 in Na to plus 1 in NaF. Please, okay, we have gone through this before. You don't just give the numbers. You need to tell me where these numbers correspond to. 0 corresponds to Na, the element, plus 1 corresponds to NaF. All right, moving on. Carbon and zinc can be used to separate tantalum from tantalum oxide. Oh, this is a clue, right? That means what? At first, it's tantalum oxide together. Then tantalum got kicked out. Oh, this is displacement, right? This sentence means displacement because at first tantalum is together with oxygen, then it got kicked out, displaced. This means that carbon and zinc can displace tantalum, which means that tantalum is less reactive. Okay, but let's not stop here. It's less reactive than, yes, carbon and zinc. Okay, make sure you write a full sentence. Don't just write it's less reactive than what? Than carbon and zinc. Okay, so that's part 3 done. Now part 4, part C, part 1 is mole concept. Let's go through it together. Now, most students that year were very scared of mole concept, and this question didn't help because this question looked very complicated, but actually it's not, right? So let's finish part 3, then we'll go to C part 1. All right, so if I'm done, can you give me a thumbs up so that I know you're done? Okay, the mole concept, please don't skip. Mole concept is supposed to be easy, right? Calculate the mass of 1 mole of potassium heptafluorotantalate. Now, please, let's not be scared just because the name sounds horrendous. The formula is here, right? They're asking for the mass of 1 mole, right? A mass of 1 mole, mass of 1 mole is just the MR, right? So the mass of 1 mole of K2TAS7, just need to add everything up, right? So 2 times 39 plus tantalum is 181 plus 7 times 19. So with that, use your calculator, slowly work it out. 392 grams. Okay. So you need to add up, basically find the MR of K2TAF7. Okay. And remember, like I said, combined science very often, they try to help you. They actually give you the ARs already. Okay. It is. It's at the bottom. Tantalum is in the periodic table. So it's one of those rare metals at the bottom of the periodic table. That's why it's very hard to find. Now, the mass of 1 mole of substance is equals to the MR. That's the definition of MR. Right? All right. So moving on. So now that you have the mass, the MR, what can you do next? 2,000 grams of tantalum. So now you must convert this to mole. Number of mole of tantalum equals to 2,000 grams divided by the AR. Not 392, it's tantalum, not potassium heptafluorotantalate. Tantalum is Ta. Okay, so don't make careless mistakes. So this is 11.050 mole. You see that I give to 5SF because this is not the final answer. Please do this. Do not round off too early. 5SF is good enough. Please don't copy out the whole string either. That's a waste of time. All right, tantalum. Okay, then you want sodium, right? Tantalum is to sodium. So the tantalum is 1, sodium is 5, 11.050 times 5, right? So that gives you 55.25 mole. Then the mass of sodium, you just need to take 55.25 times the AR, which is 23. 127 0.75 grams. So if you want 3SF, 1270 gram. Okay, so you could have given 3SF or you could have stated 1270.75 also can lah. Now, when do you decide to round off or not? Actually, 1270.75 is not too long. You can just give the exact answer. But you must round off when you see that your calculator has a very long string. If it's a very long string of decimals, you must round the final answer to 3SFs. Okay? That's fine. Or 1273. Both are okay. All right. They will not. Yeah. No fractions. That reminds me. No fractions are mole concept, chemistry, physics also no fractions please reminded me no.
Wait, teacher, I thought the equation can write in the fraction. The balance equation.
Sorry, the balance equation is it?
Yeah, I can write in fraction, right? I remember. In front.
The coefficients for the equation can be fraction, but what he means is the final answers. Do we put final answer in fractions? No. That means let's say if it's 1270.75, we don't go and put 1270 3/4 no fractions. No fractions. All right. Okay, so that the students in front of me reminded me. That's why I decided to remind you. Okay, no fractions, please. Okay. Same for physics. Okay. If the answer is 3/2, you don't write 3/2, right? You write 1.5, right? Yes. Okay. Now, there's a reason for this. I think I've explained to some of you before. Now, when we write things as fractions, like 3/2, yes, fractions are accurate, they're exact. So you are suggesting that your experiment has no errors. But now you look back, is it possible for any experiment to be perfect without errors? The answer is no, right? Because very often in the lab, when we measure things, our instruments themselves have an error. Burettes have a certain error. Measuring cylinders have a certain error. So you must round off to ensure that, okay, your answer is not overly accurate. When you give as fractions, you are giving the wrong impression that you are perfect. But actually your experiment is not perfect. Okay? All right, moving on. Section B. Now, okay, let's continue, right? Now, relative molecular mass, many of you have forgotten how to define it. Now, relative molecular mass is the average mass of one molecule, not atom, molecule of the substance compared to 1/12 of the mass of a carbon-12 atom. So whenever you see relative mass, relative means you compare with 1/12 of the mass of carbon-12. You know it's molecule because it's relative molecular mass. All right. Now, Mr. So is going to skip B part 1. I'm just going to give you the answer quickly. Now, I will also skip calcium chloride because calcium chloride, I think you know how to draw it yourself. If you don't know how to draw it, you can draw it yourself. Let me see later via WhatsApp. All right. I don't want to go through calcium chloride. I want to go through ethane. Okay. So once we are ready, we go straight to ethane, which is the next page. How do you draw the dot and cross diagram for organic molecules, which I went through during the organic chem summary? Okay. So are we done? Okay, I'm going to move on. Okay, ethane. Now it's organic. When it's organic compound, don't start with the dot and cross. Don't start with dot and cross. Draw the structural formula first. I repeat, always start with this first. Do not start with dot and cross. Next. Because you started with this, you will know whether it's single bond or double bond. They are all single bonds. Not surprisingly, right? It's an alkane. Alkanes don't have double bonds. Okay, The next problem is, because there are so many atoms, should we invent new symbols to represent the electrons beyond dots and crosses? The answer is no. There is no need to invent new symbols. You could just use dots and crosses throughout. All right. And it's easier to do it this way. And they are all single bonds, so it's just one dot, one cross. And that's the answer. All right. That the examiners do not expect you to come up with a third symbol. Don't need. You just stick to these symbols. All right. However, okay, this is what you need to know. However, if you want to come up with a third symbol, now this one is just using dots and cross easy. If you want to come up with a third symbol, you need to be careful what you come up with. Cambridge will not accept anything other than dots and crosses. So instead of doing dots and crosses, what variations can you have? Okay, so watch what I'm doing. I will use a dark circle and a white circle. These are the only symbols that Cambridge will accept. If you really wanted to come up with a different symbol, you should only use a white circle. And if you come up with a third symbol, what you need now is a legend. So you must be clear that X represents electrons of hydrogen. The dark circle represents electrons of the first carbon atom. And the white circle represents the electrons of the second carbon atom. So as you can see, right, there are two ways of doing this. Either you just stick to dots and cross, or you come up with a third symbol because you want to differentiate the two carbon atoms. But once you do that, you must be very careful, because once you do that, you must have a legend. If you don't have a legend, it's wrong. Okay? Can? No, I put dot cross, dot cross. So you can see, even though these are two carbon atoms, I would recommend you just use dots and crosses, even though they're the same element. Just alternate dot cross, dot cross. All right? Now, at this juncture, I want to show you and repeat what I went through during the organic chem summary, which some of you didn't attend. If you go back to consults and revision, I've gone through organic chem summary that day, part 2, I think. Look at how Mr. So drew my alkene. Okay, C2H4, ethene looks like this. The double bond, you can see, is dots cross, dots cross. Even though both are carbon atoms, I just alternate the dot cross, dot cross. All right, this is how you should draw ethene with a double bond. Okay, so if you are lost, this is under consults and revision, organic chem part 2. The video is also on YouTube, which you should have watched if you didn't attend this summary. All right, so this is 2020 paper 3, ethane. All right, so let's take it down. All right, so with that, let's go on to question 9. I'll skip C as well. Part C, we can skip. Then what you can do it yourself. I want you to do it yourself and try it yourself. Okay? And show me if you're unsure. Okay, so are we done with ethane? If you're done, can you give me a thumbs up so that I know I'm done? We'll just go to question 9 and we'll stop at question 9 actually. Okay, Ishika, thank you. How about the rest? Are you done with drawing ethane? All right, question 9. All right, ethane, alkane CnH2n plus 2. Alkene CnH2n. This one I think is straightforward. We should be scoring. Okay, part B. Members of the same homologous series have the same general formula. State 3 other characteristics. Other means you cannot repeat same general formula in your answer, right? First one, they should have similar chemical properties due to same functional group. I think I've mentioned this many times in class. This is one property. So this functional group and chemical properties is 1 point. The next 1 point is that they should show or display a gradual trend in their physical properties. So the physical properties are not similar. They are actually different, right? There's a gradual trend in their physical properties as the number of carbon atoms increases. No need. So that's point number 2 already, right? Okay, next one. They should differ consecutive members. Differ from each other by a CH2 group. Okay, so when did we last go through this? We went through this during organic chem, part 1 summary, okay? About 3 marks, wow. Okay, so it's easy if you study it, all right? Next, you are to distinguish between 2 gaseous compounds. Now, they are gaseous, gaseous. So they are gases. Gases can only be bubbled into another liquid. So one is propane, one is propene. Okay, alkanes versus alkenes. How do you differentiate? You should bubble both gases into aqueous bromine separately. Okay, don't drip because these are gases. Gases can only be bubbled. Gases cannot be dripped, right? So what's the observation? Propene, the alkene, will decolorize aqueous bromine from reddish brown to colorless. All right. The aqueous bromine will remain reddish brown when propane is bubbled. Okay, so know the difference between the two. Propene will decolorize aqueous bromine from reddish brown to colorless. You could say that propane will result in no visible change observed. Okay, also can. Okay, so now write the balanced chemical equation. This one is where it's hard, right? Propene is the one that reacts. Propene is C3H6. How I know it's C3H6? Because it's CnH2n. Okay, propene plus bromine. So this one is addition, right? Addition means just add together. Okay, so that's the equation that you must write. Okay, this one is 2 marks. So the equation, again, don't leave it blank. Make sure you try to write propene is C3H6 plus Br2. Now this one is addition. Addition means just add together. There's only one product anyway, right? So just ensure that the C3H6 and the Br2 come together in one product. Okay, so remember this is addition. Okay, so with that, we have actually been going through. Now, before we end the recording, I want to stress to you the importance of studying for every single chapter. Okay, if you don't study for every single chapter, you may realize that there are certain things that you have forgotten, and unfortunately, you didn't manage to revise it before the O-levels. A good example today, we went through distinguishing tests. Aqueous bromine is used to test for alkene. Test for alcohol, acidified KMNO4. Test for carboxylic acid, sodium carbonate. So these are things that you should try to remember and recall before the O-levels. So from now till Thursday morning, Thursday afternoon, sorry, you should try to learn these things, okay? So make sure you get all these things in. The remaining questions, I will put the answers up onto our OneNote, and I'll inform the class chat group when it's done. All right. Thank you. Bye-bye.